There will be, again, ample opportunity for Q&As. There will be 4 sections, and we'll do a kind of a brief Q&A after each section, and then after the whole presentation, there will be a longer Q&A period. And so we're really looking for your feedback and thoughts and engagement in this discussion. We want this to be an open dialogue, and so, just provide as much engagement and questions as you can. This is very much a community-oriented event. So I think that's it for me, unless I'm forgetting something, but if I am, you can fill in the blanks. So I'll hand it over to Mark.
Thanks, Anna. Can everybody hear me okay? And, as we go through this, just there might be some slides that look kind of small on the screen because it's a relatively small screen. And just feel free to move forward if it's going to be easier for you to see. So just kind of bear that in mind. So we'll go through here, and this is kind of our agenda today. So we're going to do a little bit of introductions. I'm Mark Rosenkrantz from Aquatic Insight, an environmental firm down in Portland, Oregon. And I'm working with Rob Anir from Anir Water Resources. He's down in Portland as well. And then Dr. Seebacher from, used to be from Ecology. A lot of you folks are probably aware of her. She's helping us out on this project as well. So I'll be starting out, and then we'll do a little bit of background, a little bit of introduction about the lake, and then hand it off to Rob to talk about water and the nutrient budgets, and then back to me for management options, and then Elizabeth for some of the funding options, and then we'll do some broader discussion. So we're hoping to have the presentation part of this maybe a little bit more than an hour, and then the rest of it just kind of more question and answers or clarifications, and just more of a dialogue with you folks to see what your experiences are on the lake, and if you have any questions about what we presented. With it was a really great discussion during the virtual event. We had a lot of really good engagement, a lot of good comments, and so we're kind of looking forward to that dialogue with you folks here today as well. Already did that. Okay. So section 1, we're going to talk a little about the nutrient cycling, some background, and some monitoring results. Now, the nutrient cycling, this is just, for those of you that aren't familiar with limnology, this is just a little bit of this kind of a really high-level talk about where nutrients come from in lakes and why it's important. So lakes in general, nutrients, we're talking about primarily phosphorus and nitrogen. And there's 2 primary sources or primary ways for those to get into the lakes, and those are external and through internal sources. And your external sources are essentially anything coming from outside of the lake, falling in the lake or running off of the lake or discharge from storm water or something like that, versus internal loading, which is processes that are happening inside the lake that allow phosphorus to come from the sediment primarily. And so that can be pH conditions, oxygen conditions, or bioturbation, so sediment just kind of being mixed up. Now, groundwater is kind of its unique little bucket there because it could be an external load, but it's coming into the lake through the sediment. So it's really hard to tease out where exactly the source of the nutrients are. How much of it is groundwater versus how much it is immediately released from the sediment. But we kind of include that into the bucket of internal loading, and that'll be a little more clear later as we talk about some of the nutrient sources for Wiser Lake in particular. So we talked about internal loading, and there's a couple of processes that occur that that lead to these internal loadings. So I mentioned oxygen conditions that can cause phosphorus to come out of the sediment, and then high pH conditions that can cause the phosphorus to come out, and then sediment resuspension, and then groundwater. So just a little bit, and this may seem a little bit technical now, but it's important later on when we're talking about Wiser Lake specifically. Because what happens on a lake is during the winter, what you're looking at here is an oxygen profile and a temperature profile. And so this example is from a 20-foot deep lake. And during the winter, your lake temperature is the same from the top to the bottom. So imagine this red line is just going to be vertical from the top to the bottom. And so that means all your water up here is mixing with all of your water down here. And so there's no difference in the oxygen concentration from the top to the bottom either. But what happens during the summer is the water up in the top of the lake starts to warm up, and it's lighter than the colder water, so it stays up near the surface, and then your colder water settles down to the bottom. And so the result is your water up here does not mix with your water down here. And so if you have a lake that has a lot of organic material on the bottom that's consuming oxygen while it's breaking down, then it leads to a profile like this, an oxygen profile like this, where the oxygen at the bottom of the lake is being consumed, but it's not being replenished by the water at the surface mixing down to the bottom. Because the water at the surface has all the algae in it that's producing oxygen, but there's that thermal barrier that's keeping it from mixing in the bottom. So just kind of keep that in mind as we move through this, and once we get into your lake in particular. And so the study, the data collection for this lake, we're separating, or the data was collected from a station called WL1, which is your west basin, the smaller, shallower basin, and then WL2, which is your east basin, the larger and deeper basin. And then they collected some data from the creek coming into the lake as well. And so one thing to note is that the west basin, WL1, is shallow enough that it isn't deep enough to experience that what's called stratification, where you have the different layers in the lake. But the East Basin does experience that. And so as we start looking at the data, we'll be able to explain that a little bit more. So a little bit of talking about the lake specifically. So when we're talking about external loading, remember it's everything that's coming from the atmosphere or from the watershed running off into the lake. And so there's two. We classified the watershed for the lake, meaning the area that water runs off into the lake. There's this area here, which is the water that falls on there empties directly into the lake. And then this broader area here, this is in the green, that's the water that falls on that, goes into Cougar Creek, then that goes into the lake. So kind of keep that in mind too. And here's our two sampling locations for WL1, WL2, and then Cougar Creek. And so this is important because if you're looking at how this land use is used out here, there's a lot of agriculture there. Around the lake, there's a lot of septic tanks, and then stormwater runs off directly into the lake. Then waterfowl, particularly during the migration season, There's a lot of waterfowl in here that either land on the lake and defecate directly into the lake, or onto the watershed that then rinses off or washes off into either directly into the creeks, into the lake, or down into groundwater. I meant to ask this earlier. So, show of hands, who lives on the lake specifically? Okay, a few of you do. Good. And then your other folks are just kind of around. What is, your interaction with the lake, but you don't live on the lake itself then? Okay. So, back to, I was talking about stratification. We'll just go through this really quickly. So, this is a profile. Remember how the profile that we saw earlier, where this yellow line went all the way to 0 on that deeper lake. It doesn't go all the way to 0 in Wiser Lake. This is the bottom of Wiser Lake, and it doesn't quite go all the way to 0, but you start to see some decline in oxygen. Even though you're seeing a fairly straight line on temperature, you're still seeing some oxygen depletion. And so there may be, there is an indication of internal loading from the sediment as a result of reduced oxygen, but and we'll talk a little bit about why it's not showing up that way in our profile here. Let me make sure I didn't miss anything here. Okay, so then we're going to go into the data slides that may be a little bit difficult for you to see. But this is important because the reason that lakes have a lot of algae or plants or cyanobacteria is because they have a lot of food for those. And so if you have a lake like Wiser Lake, which has a lot of phosphorus in it and a lot of nitrogen in it, you're going to have plants and algae that want to take advantage of that and produce a lot of biomass. And so if you look at, this is, these are our nitrogen concentrations in the lake. And this is the dates on the bottom here are the period of the study where Anna and Josh were collecting data for the lake. I guess it was Anna. From May of 23 to mid-April of 2024. And so you can see during the summer, if you're looking at our nitrogen, it's pretty stable. It doesn't change a whole lot during the summer, but during the winter, it really, really goes up. And so the total nitrogen and our nitrates. And what that's telling us is the watershed is contributing a lot of nitrogen to this lake. And if we go back a couple of slides, you remember this is a lot of agricultural land, so all the activity that's happening on that lake during the summer, then when the rain falls on it, that all kind of washes out into the lake. So that's kind of the story on our nitrogen. Now so that's our phosphorus. But before we get there, I wanted to show you our concentrations of these nutrients, our summer average, our annual average, and our maximum concentrations. And I want you to focus on phosphorus. So for a lake where we're trying to reduce our algae and cyanobacteria blooms, we want a phosphorus concentration of around 20. And we are many times that in the lake. And so, kind of bear that in mind. Now, we have three sources of phosphorus here. Just kind of go briefly, or two sources of phosphorus are total phosphorus and what's called orthophosphorus. And orthophosphorus, just really quickly, Total phosphorus is all the phosphorus that's contained in algae, sediment, whatever happens to go into that bottle. Analyze that. That's all the phosphorus that's in the water. Versus your orthophosphorus is they filter out all those particles, and that's the phosphorus that's dissolved in the water. And that's important because that is the phosphorus that's immediately available to feed algae and plants. The total phosphorus has to be changed into orthophosphorus. So orthophosphate is super high as well. So, you've got a whole bunch of phosphorus that's available to feed algae in here, as you can see here. And so as you noted from the nitrogen slide, you can see that the nitrogen starts to increase during the winter when we start to see flow coming in from the watershed. But if we look at our phosphorus slide, that increases during the summer, where there's relatively little flow coming into the lake. And so that indicates that that is coming from an internal source and not an external source, because it's, the creek is really not flowing very much into the lake during that time of the year. And so this is WL1 here, which is the west basin, the total and the orthophosphorus concentrations as we go through the year. I broke the east basin, the deeper basin, up into the top and the bottom, and you can see that the phosphorus concentrations, again, are increasing during the summer. And then the creek, the phosphorus in the creek wasn't really that high. So it's not like the creek is contributing a whole lot of phosphorus compared to, like, for instance, the east basin. So the creek is not contributing all this phosphorus. It's coming from the basin itself. So that's an important factor when we're talking about management options later. And again, the orthophosphorus in the top and the bottom of WL2, the east basin. And okay, and then one other thing is that we talked about oxygen, the oxygen profile in a previous slide, which is showing this what's called a sonde, where they lower it down and they're measuring the oxygen as it's going through the water column. This is a time series where we're looking at the oxygen concentration near the surface and the bottom as we're going, as we're comparing those on all the dates throughout the sample period. Now, the shallow basin here, the temperature doesn't look like, it looks like it's the same throughout the year between the top and the bottom. The same thing on the other basin. The temperature looks the same throughout the top and the bottom. Now, they're collecting this data around noon, was it? To 2?
Sometime between 10 and 2.
10 to 2, yeah. And so that's in the middle of the day. Middle of the day out here, and, help me with this, tends to be kind of windy, right? And so this lake is pretty well mixed at that time. But yet, we're starting to see a separation in our oxygen concentration between the surface and towards the bottom. So even though the lake seems to be totally mixed, we've got a difference in oxygen between the bottom and the top. So why is that? We'll talk about that here in a little bit, I'm guessing. Looking at my notes. I'm just going to mention it now. So and since we talked about wind mixing during the day, what happens at night, right? Usually what happens at night is the winds calm down and for a few hours at night, and then they pick up again the next day. So what could be happening, and the reason that you're seeing lower oxygen, even though you're seeing the same temperature, is at night, the lake becomes more stratified. You remember how we were talking about the stratification before. And so when you're doing that profile during the middle of the day, when it's windy and sunny and all that mixing is happening, it looks like it's the same temperature top to bottom. But if that was to be repeated at night, when the weather is calm and the wind isn't mixing the lake, and that biological activity is still happening in the bottom of the lake to consume oxygen, but you're not getting the wind to mix that bottom water to the top water, you could very well see quite a bit of oxygen depletion at night that you're just not seeing during the day when you're sampling this lake, right? And so you would still see, what may be the temperature the same, but the oxygen hasn't recovered from that reduction in oxygen concentration that happened at night. So that's, again, an important concept to think about when we're thinking about management options. So a couple more things. I don't want to run out of my time, but another thing, they collected sediment core data. And so the reason that you do this is to try to figure out, okay, so if we have a lot of phosphorus that's coming out of the sediment, how much phosphorus is in the sediment, right? And how much of it is available to be released up into the water column. So colors look a lot different than what they look like here. So this is the West Basin and the East Basin. You can see they're quite a bit different. And what they do is they shove a tube down into the lake, and then every 5 centimeters, they slice off the sediment, send that away, and have them do analysis of it. And so they did that at 0 to 5, 5 to 10, all the way down to 30 centimeters here, right? And so in the top 5 centimeters, the orange is iron-bound phosphorus, and the green is organic phosphorus, and the light green is organic, the dark green, which, yeah, that is dark green, believe it or not, is aluminum-bound, biogenic, calcium-bound. You're just different fractions of phosphorus. The important ones are the iron-bound and the organic, because those are the most available. And iron-bound is really important because, remember we were talking about anoxic sediments earlier? That's what happens when you have anoxic sediments, is the phosphorus that's bound to this iron, poof, it gets liberated, and the chemistry changes in there so that the phosphorus and iron-bound the phosphorus and iron complex is broken, and the phosphorus is released in the water column, right? So the point to keep in mind is that if you have a lot of iron-bound phosphorus in the bottom of the lake that has the potential to be anoxic at the sediments, you're going to get a lot of phosphorus out of those sediments. And then the organic is the phosphorus that's in the organic material that the biological activity is kind of working on to break down. So at the end of the day, there's a lot of phosphorus in the sediment in Wiser Lake, particularly in the larger East Basin. And another thing we talked about was pH conditions that can lead to phosphorus being released from the sediment. And that is the aluminum-bound portion right here. It's these fractions right here. And when your pH at the sediment reaches 8 or a little bit above, then you start to see phosphorus releasing from aluminum. So under anoxic conditions, you're going to see phosphorus released from iron. And remember, there's a lot of iron-bound phosphorus in the lake. And then at pH at 8 or above, you're going to start to see phosphorus released from aluminum. So looking at this, you can see that there are times of the year where the pH in the lake is at or above 8. And so, again, there's another factor that is leading to this internal release of phosphorus. Is that, there we go. Sorry. So a takeaway from all of this, possible stratification light, and then, the high pH is just caused from photosynthetic activity in the water column where all this algae is converting energy to carbon and increasing the pH. That's where because typically lakes with a high pH are very productive, meaning there's a lot of plant life and a lot of algae happening in there. Okay, moving on. So we mentioned waterfowl in the watershed and how that can have an impact on the lake. So there was a study done back in 23 and 24 where they were doing bird counts. Now we don't know, these are general bird counts, so we don't know if they were on the lake or on the watershed, but they just knew that they were kind of in the area. And so this is a very popular stopover for migrating birds, and in October there's just huge waterfowl numbers. Now what the impact is specifically on the lake is unknown because, again, we don't know if they're landing right on the lake, how many of those are landing right on the lake and just mainlining their defecation right into the water, or if it's going into the watershed to be transported to it later. We don't know that, but we do know that there's a lot of waterfowl that go through here, and you folks that live here probably experience that. Just a lot of ducks and geese and swans on the lake. So that's, again, another contributing that would be considered an external load. So what was happening in the algae in Wiser Lake over this study period? So, and this is typical. Oh, I'm so sorry about these colors. This is so typical of lakes. Is in the spring, where the water is cool, and you're starting to see enough sunlight to be able to feed algae. Your really rapidly growing diatoms are going to be dominant in the spring, and we see that here. Not so much in the not so much in the east. There we go. This is the east basin. So you see your diatoms here, and then it shifts over. This green here is Cyanobacteria. And there's a little bit of Cyanobacteria activity in July, and then a whole bunch of it in October. And so this is the overall phytoplankton biovolume, which is algae and Cyanobacteria. And then this is the species of Cyanobacteria that were present when they were present in the lake. And mostly what we had is called Anabaena flossaque, which is a Cyanobacteria that, I don't know, you folks, are you aware of Cyanobacteria in general? Kind of the fun stuff that Cyanobacteria can do that allows it to outcompete other algal species is they can fix nitrogen, which we'll see later could be important. They can adjust their buoyancy in the water column. And so when you see, and so that's important because they can migrate down deeper in the water column to access nutrients, and then they move back up, and then they can use sunlight to convert those nutrients to energy. They create toxins, which is what everybody is concerned about. They have the potential to create toxins. And the aquatic insects, the zooplankton that usually eat algae, they don't like cyanobacteria. And the other thing is they make colonies. And whereas diatoms are individual algal cells, cyanobacteria can join together into long filaments or clumps or other structures that makes it hard for them to be consumed by the aquatic insects, and again is more of a defense mechanism. So, and if you're the most important thing is, of course, the toxin production. Nobody likes that, and the buoyancy. And during times of the year where you're starting to see films on the lake, bright green colors, that's because the cyanobacteria have become buoyant, have kind of stayed on the water column. And of course, unfortunately, that is where dogs and swimmers and everybody interacts with the water. They're right there at the surface. So it makes it really unfortunate for lake health if you have a lot of cyanobacteria. So this particular one, again, it's a nitrogen. Not all cyanobacteria are nitrogen fixing. Many of them are. Anabaena is, and so that's an important consideration on this lake. Now, on the East Basin, the larger basin, the concentration of cyanobacteria in October wasn't quite as high as it was in the. Am I backwards here? Yeah. In the East Basin, it wasn't quite as high as those in the West Basin, and there may be reasons for that, but it's maybe because the wind blowing, the wind blowing action or some other reason. But at the end of the day, it's just you've got a lot of cyanobacteria in certain times of the year. Now, this is just 1 year, and maybe there's other years where they have more cyanobacteria at different times of the year. It all depends on the weather and the conditions that are leading to this growth. But this is kind of a snapshot of this particular time. And then excuse me, more data. We're almost through this. Thank you for your patience. The other thing that they do is they measure chlorophyll and what's called phycocyanin. So the chlorophyll is, green plants, they produce chlorophyll. So just like algae and cyanobacteria, they produce chlorophyll. So you can have a sensor in the lake, or you can take samples to measure the chlorophyll throughout the year. And these kind of mimic what was happening in our on our phytoplankton slides that you just saw. But what was interesting here is the orange line is our phycocyanin, and that is produced by cyanobacteria. So it's kind of a nice way of being able to take the pulse of a lake and see, it kind of verifies our cyanobacteria activity. Like even if you're not taking samples as regularly and having them analyzed, you can look at your phycocyanin concentration throughout the year and see when the lake was dominated by cyanobacteria. So that's really important information to have. All right. And then another thing that's kind of interesting is the a Secchi reading. If I don't know, you folks may or may not be familiar with that, but what that is, it's been used for decades, hundreds of years, I think. I don't know when thing was invented, but it's a disc like this that has black and white quadrants on it, and you lower it down in the lake until you can't see it anymore, and that gives you the transparency of the water. And Wiser is a fairly shallow lake, but still the transparency was really low throughout the year, like half a meter or so. It's between half a meter and a meter through most of the summer. Little bit better transparency in the in the west basin than the east. And when we drove by the lake today, we noticed there's a lot of brown water in there. It's a lot of tannins in the water. So I think the transparency in Wiser Lake is naturally pretty low. So it did reach the bottom in June, which is typical of lakes. Your clearest water, yeah, I know. Clearest water is in June. I just love talking about lakes. I'm sorry. So we'll just kind of move on. Let's see. Oh, so the important thing about this is I mentioned the nitrogen-fixing cyanobacteria species. And that's important here because if you look at, I'll just make this really brief. There's an optimal ratio between nitrogen and phosphorus, about 16:1. That's kind of what plants, if you grind up a plant and analyze it, it's got about 16 nitrogens to 1 phosphorus. But the lake itself was below that ratio for much of the summer, which may be the reason why we have nitrogen-fixing cyanobacteria that are dominating, is because other algal species might have been nitrogen limited. There's tons of phosphorus in this lake, but compared to how much phosphorus was in the lake, there wasn't as much nitrogen. So that might have been leading to our nitrogen-fixing cyanobacteria. All right, and that's it. Our last slide here. It's kind of summarizing high summer phosphorus due to internal loading, sediment resuspension from wind mixing or fish stirring up the sediment, anoxic sediment potential, anoxia at night due to calm wind conditions, and high pH due to photosynthetic activity. Cyanobacteria, despite the high phosphorus, there was relatively low phytoplankton growth that might have been nutrient and light limited, but did have high cyanobacteria during the October period, dominated by nitrogen-fixing species. And which maybe during the day and during certain times of the year, the wind mixing, I didn't mention this, but the wind mixing also reduces the ability of cyanobacteria to adjust their buoyancy and reach their optimum growth areas in the lake. That was a lot, and thank you very much for your patience. So any questions about any of that, or you can hold your questions to the end. And yes, please.
You showed a slide that had the large amount of iron that broke apart. What's happening with all that iron? Is it just continually settling in the bottom of the lake and accumulating, or does it attach to something else later?
Yeah, so what happens, that's a great question. So what happens with the iron is, the source of the iron is hard to say, right? So you've got the phosphorus. When there's oxygen at the sediment, the phosphorus and the iron are bound together. When there's no oxygen at the sediment, then that phosphorus is released from the iron. But then if, like for instance, what could be happening here is during the day, there's oxygen down there, and then that iron can bind with the phosphorus. At night, there's no oxygen. The iron throws the phosphorus up into the water column. Then during the day, when there's oxygen pushed down there again, the iron grabs onto that phosphorus and pulls it in again. So it's a cycle where, during oxygen, when there's oxygen down there, then it's grabbing that phosphorus. When there's no oxygen, then it's throwing it away. So, it's just kind of a continuing cycle depending on the conditions at the sediment. Great question.
So, on that, what's the sense of what percentage of the time do you have anoxic conditions in that year's data?
Yeah, we don't know, and we can, and Rob will talk about the modeling that he did about the phosphorus sources and how much is coming from the sediment. But without knowing, and we're going to talk a little bit about this later for next steps, is without knowing how long or when that sediment is anoxic, or if at night, it's hard to make those judgments. So what you would have to do is just kind of measure over time how often the sediment is anoxic and then remixed and things like that to be able to better calculate. We can make estimates, but in order to really nail down that, you would have to make some more measurements. Oh, sure, Rob.
So the samples that were collected were like once a month, once every couple of weeks, and it was during the day. What we don't know is exactly what happens at night. We suspect what Mark is saying simply because we see those nutrient increases during the summer. But the way to confirm that and to get to the duration of low DO overnight is to literally put out some instruments that can either be out there overnight or someone does a profile at night, that kind of thing. But you're getting to a really good point is at some point we do need to better understand that, is how much time and spatially, how much of the lake does that at night.
So right now, though, it's a supposition as to what the anoxic conditions are at night.
Yeah, it's a pretty good supposition, though, in a sense because of the volume or the mass of phosphorus that we see occurring during the summer, and it's not, as Mark was saying, not coming from the creek. There's just not enough of it. Does that make sense?
Okay, thank you. I'm sorry.
You had mentioned that, this was kind of a snapshot that was it mostly 23 to 24 that this data was taken? And so how reliable would you say in your judgment is that over many years, right? Obviously we could sit here and do this another 7 times, but that doesn't make sense. Do you feel like there's enough data with what has been collected to make accurate and helpful recommendations?
Yes, we do believe so because it's going to change a little bit from year to year, but the basic premise of where the phosphorus is coming from isn't going to change dramatically. It's just a matter of how much from one year to the next is coming out of the sediment and, the timing of it. And you're going to have a different algal population and timing of that throughout the year. But it's not going to change the recommendations as far as that goes.
Any other questions?
And again, there'll be time for this, plenty of time, hopefully, after we've finished up.
Just to sum up that, you're saying that I get it right. Yeah. If I got this right, that you're saying that the most of the phosphorus is coming from the sediment.
Right.
Is that
that's
right?
Correct.
Okay. That's all I wanted to know.
Yeah. Most of the phosphorus is coming from the sediment. Most of the nitrogen is coming from the watershed. Yeah.
Hi. So one of the things we wanted to do is to take this data that was collected over 2023 to 2024 and make some sense of it on what we call a water budget. How much water is coming into the lake? How much water is leaving the lake? Where's it coming from? What are the sources? So we took a lot of that monthly information and compiled it into what we call an annual budget. So I'm going to see if I can get the technology to work. Don't want to point the laser at someone. So what we have here is this is an annual budget. This is a nice little pie chart that shows stream inflow. This could be also considered outflow, flow going in and out of the lake. We have the next largest chunk here is precipitation. So we have the flow is 56%. No surprise, you've got a pretty dominant creek that flows through. Precipitation, given the surface area of the lake, 24%. And then overland flow. If you remember, Mark showed a map where there's this land that's outlined in green, that's the watershed upstream that goes into Cougar Creek. And then there's the land that's immediately or closer to the lake itself that drains to the lake. So what you can see here is these three components make up the majority of your budget, water budget. The smallest component, and also the most uncertain, is the groundwater, simply because there isn't a lot of groundwater monitoring data. There isn't a lot, like no one's built a computer model of the groundwater, etc. So what you see in this table is what we call net groundwater. They were putting at about 32 acre feet. And so again, these are rough calculations, meaning that on an annual basis, we think about 1,100 acre feet is coming into the lake and a similar amount is going out of the lake, because you don't have a large change in the water level of the lake. Large being, it's not drying up or that kind of thing. And so, but some of those, the components are the inflow, the precipitation, the groundwater, the overland flow, and certainly what goes out of the lake, and then you obviously have some evaporation losses, okay? And so what's really uncertain, as I said, is the groundwater, but it's dominated by the flow coming in and going out. We then wanted to look at the nutrient budget. This is a very busy graph, but this is the waterfowl information that Mark was showing a few minutes ago, just plotted a little differently. And so what's in blue are the counts of ducks. In orangish tan is the geese and swans, and the gray is the rest of the bird classifications. And this is an amazing data set, I have to say. It's great, but it's not enough for us to say this is how much nutrients the waterfowl are causing to go into the lake. And there's a couple reasons for that. We looked at, this is, like I said, a great data set. We looked at some of the past methodologies other scientists have used to quantify how much nutrients are being contributed to a lake from waterfowl. What we learned is that while these bird counts are really valuable, it's not enough to give us a complete picture. Mark hinted at that earlier about how much the waterfowl are actually on the lake and defecating in the lake as opposed to on the land. In addition to that, all of these birds, whether it's other geese or swan or ducks, they all have different sizes. And based on the size, how big, mature, young the waterfowl are, there's a rate at which they would defecate at. And that has been studied some by scientists, but not enough. And that also includes how much nutrients are actually in their waste. Lastly, some studies have shown that waterfowl actually cycle the nutrients. So for example, if a duck comes and hangs out for 2 months at the lake, it may be literally eating stuff in the lake, defecating back into the lake, and so those nutrients just kind of cycle in the lake. One study showed that was 87% cycling of the nutrients. So it makes it really difficult without having some of those other numbers to actually give a value to say waterfowl are causing X% of the nutrients to the lake. So it makes it highly uncertain. So one paper showed it was 70% of the phosphorus loading. Another showed it was 27 to 34%. It's a pretty wide range. So as a result, we didn't specifically include this in the nutrient budget, but we have a lengthy discussion in the lake management plan. So you can see all the gory details we went through, or myself and my colleague did. So that's where we get to this nutrient cycling and the usage on the lake itself. We just have bird counts. We don't know where they are when they counted the birds. So while there may be 34 ducks, 34 geese and swans, and 4 at this particular date in May, we don't know where they were. Were they on the lake? Were they next to the lake? Were they simply in the watershed nearby? So that made it kind of challenging to interpret. Looking at the nutrient budget, on the left-hand side we have nitrogen, on the right-hand side we have phosphorus. This is for the whole year. So this is going to mask what Mark was talking about earlier, where the nitrogen is heavy coming from the watershed in the winter, and the phosphorus is heavy coming from the lake sediments in the summer. So this is an annual basis. But what you can see on the nitrogen side is it's the majority, 80% of it, is literally coming from the watershed, passing through. Overland flow is pretty small. Septic is really small because we just don't know. We do know that there are septic systems throughout the watershed. Some of them are being maintained. Some are on sort of a watch list, if you will, because maybe they haven't been maintained as well. And certainly aerial deposition is a component. There's always nitrogen in the atmosphere. We need it to survive, and some of it gets naturally deposited. When you look at the phosphorus, it's a little bit more mixed. We have some inflow coming in. We have some overland flow from more adjacent to the lake. We have this internal loading, and then we have septic and aerial deposition. So here, this looks a little different because we're looking at it on an annual basis. If you looked at this at the summer, this internal loading wedge, pi wedge, would be much bigger. Why? Because you don't have much stream flow coming in and you don't have much overland flow. It's a lot drier in the summer, right? And Mark showed you earlier the concentrations in the creek are pretty low relative to what's coming from the sediment bed. So during the summertime, you have that wedge would be much bigger than 24%, okay? So, and the septic loading itself is uncertain simply because there is a lack of information. There's lots of literature out there from all around the country and around the world about how much nutrients come out of septic systems, but often that's not as valuable as localized information because a lot of geology and groundwater matter for that. So being an engineer, we like to play with numbers, right? So there's something called the Vollenweider model and Nuremberg model. These are simple models. They're like a spreadsheet. You take the kind of nutrient budget information I just showed you, and here in this case, this is designed to look at the whole lake. So it's annual conditions, average lake surface area, volume, depth, loading per year, etc. And it sort of calculates a rough estimate of what should be the concentration in the lake. And this is in micrograms per liter, 74.4. And you can see here that the actual data is higher than that, but it's not outrageously different. This is supposed to be very coarse, and I'll explain why in a minute. Over here for this other model, again, spreadsheet, Microsoft Excel, whatever, similar type of information, volume and depth and characteristics of the lake, but this also allows us to break it down into what is the annual average concentration, what is the summer epilimion, that's the top part of the water column, and then the fall concentration. Some lakes in North America do what's called a turnover, and that means when you have that stratification Mark was describing, warm at the top, cool at the bottom, then when you get into fall and it gets isothermal, meaning the same temperature, turnover. So you get things well mixed over the depth. And so these concentrations are another guidepost for us that tell us, oh, what's nice about this is these two agree. That's good. They agree, right? They are, like I said, a little bit low relative to the data. But again, this is looking at a gross annual conditions. These are looking at the measured from the 1 year of the study. And so what's valuable about these kind of tools is if you decide to implement a management strategy at the lake or in the watershed, and you come up with an estimate of how much it reduces the load of nutrients to the lake, specifically phosphorus in this case, then you can see how this number changes. Right? Mark was talking about you're wanting to get to 20 micrograms per liter. You know, the tool can be used to say, look, an estimated load reduction to achieve that mesotrophic level is 68 to 84%. That sounds like a lot, and it is. But again, this is just using the tool as is. As you implement a project or you treat the lake or you do X, Y, or Z, you can actually use this kind of little spreadsheet to say, how much did I move the needle? How much closer am I to my goal? Okay. So in summary, the water budget itself is dominated by the inflows and outflows. There's not enough information to account for the waterfowl as to what the component might be, but that doesn't mean we don't have recommendations on what you might do in the future. The nitrogen budget itself is dominated by the stream flow. Again, this is on an annual basis. As Mark pointed out, in the wintertime, that's dominated by the watershed inflow. And the phosphorus budget on an annual basis is dominated by the stream flow and the local overland flow. But as Mark described, in the summertime, that is dominated by the sediments. And so again, the analytical tool that I just showed you has some benefits for helping guide management. And then lastly, sort of the conceptual model. So we have these large nitrogen inputs in the winter, the large sediment in the summer, the high pH, anoxia. And now we're going to get into eventually some management options. But what's really important to understand is that when you talk about watershed improvements, those can take time to actually reap the benefits at the lake. And that's okay. In-lake management practices can be short-term. We're going to treat the lake. We're going to do X. We're going to do Y. The problem is that those are only temporary solutions. They might help you for a couple of years, maybe up to 3 or 4 years, but they're not necessarily something that's going to help you keep the lake clear of algae for decades to come. And that's where you sometimes want to use a combination of these two things. Short term, you might do something, but longer term, you might do some other things to help the watershed reduce the nutrients from getting to the lake in the first place. All right. Questions? Bring it on. What would you like to know? And the big microphone will be sent your way.
Even though those are short term, like the management, as you were saying, 2 or 3 years, can't we just do it again?
It could. There's also a cost issue. Right? So you raise it really. I'm gonna go back to my. I'm gonna go to my. So you're absolutely right. So I don't want to throw at numbers or dollars, but the idea is like it might cost a certain amount of money to do a lake treatment. And that lake treatment might last you 3 to 5 years, okay? And then after that time, you spend the same money over and over again, right? So every 3 to 5 years, you'd spend that same amount of money. That can get very expensive. Sometimes that same amount of money can be used to do something in the watershed, and once it's done, it's going to reduce the nutrient load for decades to come. The problem is, you may not see that immediate change in the lake, because the amount you reduce in the watershed will not be the same amount that you sequester from treating the lake. Does that make sense?
It does, but most of us are here because of the lake being unhealthy, and we just want to have that lake to be healthy.
Correct.
I mean, it's very unhealthy. It stinks. You know, there's a lot of issues with it. So I understand the long term, but I think, and I don't know what the costs are because you haven't actually addressed that, but
Right.
Shouldn't it be cost affordable if it's a health issue?
Yes and no. You're absolutely right. You'd think it should be a priority, but the problem is that there are a lot of lakes, not just in Whatcom County, but all across the country, Washington State, for example. And so a lot of these lakes have similar issues in the sense that too many nutrients causing algal blooms, cyanotoxins, it stinks, it smells, it threatens dogs, people get rashes, etc. Totally get that, right? And I'm not suggesting you shouldn't do a short-term solution. All I'm saying is that the short-term solution to keep repeating it every 3 to 5 years can end up being way more expensive than eventually reducing the loads. So that's why it's sometimes a combination of the two. So you might literally do the treatment and maybe it lasts 7 years. But the point is you don't just do anything in between. You might actually then say, well, what can we do in the watershed in the meantime? Now that we've sort of fixed it temporarily for the next few years, what can we start to do in the watershed so that the next time we treat the lake, maybe we don't have to treat it as much because we've reduced some of the loading from the watershed. Does that make sense? It makes sense. Yeah. So it's not meant to be one or the other, or one has to wait for the other. It's more that it's a combination. We want to think about, because it does cost money. And whether it's Whatcom County, the state of Washington, or anyone else, we don't have unlimited budgets. And so the question is how do we fund it over the long term?
So you're going to go over the possible treatments now too?
Totally. Yeah, absolutely. Yeah. Thank you. Other questions?
Can you tell us what the difference of nitrogen coming in this inflow was from the summer to the winter?
Yeah, so Mark showed that. You're going to have to help me, Mark, on which slide that was to go back, but I might get it. Got to put my glasses on to look at the screen. Yep. I passed it? Or is that nitrogen there?
Oh,
Yeah, that's nitrogen. So this is the nitrogen concentration in micrograms per liter, and the red line is total nitrogen. The blue line represents nitrate, nitrite, which is more biologically available. But what you can see here is this is the winter in this block right here. So as the flows are increasing in the wintertime from all the rains, we're flushing more nitrogen out of the watershed into the lake.
Okay, thank you.
Other questions? Oh.
I was just wondering, you show that the septics are a pretty small part of the whole issue, but did they look at septics in the watershed of the creek as to what, oh, they did, okay.
Yeah, so the reason why it's a small portion is because it's really unknown. Like if we went out and did an intensive study to say, and took whether that's measurements or went door to door and asked people when was the last time you pumped your septic system, we could get a better understanding of that, but it's not going to move the needle significantly. It might go from 1% to 5%, but it's not going to go to 20%. Does that make sense?
Yeah, I was just wondering if, if there was a percentage of septic that's attributable to the inflow.
Correct, yeah. And that's definitely something that should be considered going forward, in the sense that I know that some parts in Washington and in Oregon, for example, there are septic incentive programs that encourage people to get them maintenance regularly to reduce that loading. And that's certainly something you should consider for this community. Is there ways to incentivize people financially, educational-wise, whatever, to get their septic systems treated that will reduce the loading? But back to the question earlier about short-term versus long-term, if you've got someone who's, I don't know, quarter of a mile from the lake, but in the watershed, and they fix their septic system, you're not going to see the benefit to Cougar Creek for years, because you got to see the load reduction and it's got to go through groundwater. Is it worth doing? Absolutely. Absolutely worth doing. Because the more you can reduce the loads in the watershed, the easier it is later. And if you continue to treat the lake, eventually the cost of treating the lake will go down. You've got to treat it less because you've reduced that load.
Hopefully it has to go to groundwater. It's not just going to the surface.
Correct. You're absolutely right. It should be going to groundwater, but my point is that the water flowing through groundwater takes much longer than if it was just draining to a creek, right? And so my point is just that if you fix it tomorrow, you won't see the results going from groundwater to Cougar Creek or groundwater to the lake for years to come, because you have to wait for that to migrate. Doesn't sound encouraging, but it actually is, because it's an investment. Other questions before we move on to section 3? Oh, we got another.
Is there some kind of theoretical model? Because our wet season is obviously during the winter months, and it's not growing season, so there's not really plants that are taking up this nitrogen. Is there a baseline of what's, this watershed compared to a more natural situation?
That's a really good question. So first, I'll tell you the downside. Every lake is unique. Every watershed's unique. But having said that, it is true that there are certain, like if you weren't, I'm not going to suggest you should do this, but like if you weren't farming, if the land use was back to its original land use, it would be different here. But that's not realistic, right? And so it's about finding that balance. Is it possible that some restoration projects could be done along Cougar Creek that could take up those nutrients without sacrificing farmland? Are there places along Cougar Creek that could plant riparian vegetation that would soak up those nutrients? There are lots of places that do that in the Pacific Northwest. There are even places where they put poplar trees along the creek because it really soaks up water and nutrients, and the trees grow fast. And then they rotate and literally harvest the trees after a certain period of time. Every watershed's different in the sense of what those strategies should be. from a cost-effective standpoint, and also from simply like what land is available to do those kind of projects, willing landowners, et cetera, et cetera. So it is true, what you described, it is true. In the wintertime, the vegetation doesn't need as much nitrogen, but nitrogen's always available in the atmosphere, and it's always available for atmospheric deposition. And so you do have a lot of water that just pushes through the system, the watershed in the wintertime because of the rain. I don't know what the historical agricultural practices were in the watershed, whether manure application was acceptable, how much fertilizers people used. But even if the fertilizers get to groundwater, they eventually get pushed out of the system. But depending on where that is and how much rain dictates how long that takes to flush through. I hope I answered your question.
I don't know if there's a natural increase of nitrogen, percentage of nitrogen expected in this area.
No, I don't think there's a natural one, but certainly one could, if the data is available to look at who and how much fertilizer is being applied, that I know of some communities where there's a lot of collaboration on that so that they can reduce how much they're actually using. Because that's the artificial part, right? You can't really do much about the natural part, what's in the atmosphere and things like that. But the artificial part of actually applying it, some communities put restrictions if you have homes around a lake. They'll put restrictions on what fertilizers you can use on your lawn. Other communities don't do that. So I know it's not a very satisfactory answer, but yeah. I mean, it also depends on, like, in case of this watershed, what was it like, say, 200 years ago? Was it all forested? Probably not. Was it a big meadow? Maybe, right? So.
Should we, for the sake of time, should
Yep.
we cover the management section?
Yeah, thanks, Rob. And okay, so we were talking about management options here, and Rob talked about short-term and long-term management options. And so I had put a little table here together of our short-term, and phosphorus sequestration, we'll talk about that, and that is essentially putting something in the water that binds with that phosphorus so it's not available to feed algae. Aeration, we'll talk about that in a little bit, which is artificially mixing the lake during those periods when the wind isn't doing it for you. Reducing waterfowl, we talked a little bit about their contribution, and along that same line, discouraging goose residency. Like if the geese are hanging out all summer instead of migrating, then something to discourage that. And then algicides, and those are things that actually kill algae. And then long term, Rob talked about this a little bit, septic updates, agricultural best management practices, public education, using phosphorus-free fertilizers, reducing manure applications. This is a high nitrate, excuse me, this was classified as a high nitrate groundwater area. I don't know if that's what they exactly call it, but there is really high nitrate in the groundwater here. And historically, there have been field-applied manure applications. And that's important for nutrients and phosphorus too, but or nitrogen and phosphorus, particularly nitrogen, because nitrogen isn't as sticky to soil particles as phosphorus is. So it tends to move through in the wet season more readily than phosphorus does. So, and that is could be part of the reason why we're seeing such high nitrogen. So getting a little bit more specific on our management options and what we are recommending. Talked about phosphorus sequestration, and we'll go into a little more details here later. Yes, on that one. Aeration, possibly, and there's a reason why we say possibly, because we don't know exactly, like we mentioned, we don't know if it stratifies at night and the sediment becomes anoxic. If it does, this might be an option. Fish removal is always an issue. I talked about really briefly about sediment mixing up or bioturbation from fish swimming through or bottom feeding fish stirring up the sediment. That might be, but it's just not, unless there's just tons of them out there, I don't think that's going to be a viable option. Those are all for internal loading. External loading control, we talked about septic updates, agricultural BMPs, yes. Constructed wetlands, that's an option where you can use these floated or constructed wetlands or turning some of the watershed back into a wetland. I say no, that would be ideal if this whole watershed was turned back into the wet meadow that it was before it was channelized, but that's just not realistic. And you can put in floating treatment wetlands, but the amount that you would have to put on the lake in order to provide a meaningful reduction in phosphorus would make the lake pretty unusable. Stream restoration, is it possible to meander the creek coming in a little bit to allow some of that interaction? Certainly it's a possibility, but it would take landowner engagement and a lot of money and effort to do that. Phosphorus-free fertilizers for folks in the watershed. Reducing our manure applications in the watershed. Again, there may not be manure applications in the immediate watershed, but in the broader groundwater area where that stuff is coming down to the lowest point and eventually into the rivers and the creeks, that might be certainly something to look at. Mentioned the geese, treating the creek. So this one, phosphorus sequestration, we're talking about in the lake here. There's the option of treating the creek. Like if you have a creek that's has a lot of flow with a lot of orthophosphorus in it, and it's feeding the lake during the summer, you can treat a creek and remove that, settle out that phosphorus before it gets to the lake. That's not the situation that's happening here in the lake, in Wiser Lake. Now, Rob did show that the stream is a significant contribution, but that's because there's so much water that comes down in the winter that is flowing into the lake. But during the summer, there's not enough to treatment wouldn't be effective. And then these are algicides, which again, keep in mind algicides. They're treating the symptom, but not the cause. And so if you use an algicide to kill the algae, then all that phosphorus and all those nutrients that are in the algae are then released to the water column, so the next batch of algae just takes advantage of that and continues to grow. So these are, and I put only possible on these because, like if you have an area around the boat ramp or something like that that has that happens to have a toxic bloom or something like that, you can treat it at that location just to reduce the potential harmful effects of the cyanobacteria in those localized areas. But it's not something you would treat the whole lake with. It just wouldn't be an effective approach. And this goes into a lot of detail about waterfowl reduction and the methods that you can use for that. Don't really want to go into that too much. You can read it in the report. Aeration a little bit. If you're not familiar with it, you're putting a bubbler on the bottom of the lake with an air compressor up on the shore, and that creates a current in the lake to mix the top and the bottom. So that's what an aeration system does. Now, typically they're put in the deepest part of the lake, and this is, Rob mentioned this when he was talking, is you don't know if the sediments are becoming anoxic. You don't know if the sediments are anoxic over here, or only in the deepest part of the lake. So you'd have to do a little bit of investigation to find out if this would be a viable option and where. If you have to put an aeration system in the entire lake, that's a lot different than putting it in the deepest part of the lake, which is near the boat ramp, which is, fairly small area. So again, you would have to know what is happening in more areas of the lake than just that one. Again, cost depends on the extent of the system. Phosphorus sequestration, that is, your two options are aluminum sulfate and Utrizorb. Aluminum sulfate, that's been used for decades for treating lakes. It's used as the final polish for wastewater treatment plants. Aluminum binds the phosphorus, so aluminum, we mentioned this a little bit earlier in the presentation, how we had, in our sediment cores, we had phosphorus that was bound to aluminum, but that can be released from that aluminum during high pH conditions. But the goal would be to, liquid aluminum sulfate is also, when you apply it, it reduces the phosphorus, or I'm sorry, trying to get through this thing, I'm sorry. That might be an option because it reduces the pH in the water column when you're applying it. And it'll reduce photosynthetic activity, so the pH hopefully would stay near neutral, around 7, which, so it might have a secondary benefit. And it strips the water column, so it physically removes the algae and the cyanobacteria from the water column, in addition to binding with the orthophosphorus. Utrizorb, that uses lanthanum, which this is a fairly new product compared to aluminum sulfate. And the benefit, I guess, in certain lakes, the benefit of lanthanum is it does not affect the pH. And so you can add a bunch of this in the lake and you don't have to worry about your pH going too low. But it does not physically remove stuff from the water column, so it's not going to strip out your algae or your cyanobacteria. Now, if you put enough of it in, the clay carrier will remove some, but it's not as effective as aluminum sulfate is. And then it's much more resilient at higher pH conditions. Now, let's see, do I have? Yeah. So there's our when we're talking about these two treatments, and these are just planning level, we need to know a lot more about this lake and about the phosphorus release conditions and when and how and what in order to put a firm price on this. But when we're talking about sediment treatment and stripping, two different things, and they are they work together. So, and I've got both on the west and the east basin, and how much it would cost to do both of these treatments. So, stripping is where you're just applying it to the water column, and like I say, it's stripping the stuff out of the water column that happens to be in there at that time, and then that material sets on the sediment to continue to sequester phosphorus. Sediment treatment means you're doing a high enough dose that the phosphorus that's available in the lake, you're putting a cap over that sediment, so as phosphorus tries to come out of the lake, it's going to hit this cap of either aluminum or lanthanum and not be able to make it up into the water column. So that's what a lot of lakes do, is they do this kind of sediment capping application, where if you remember that top 5 centimeters or so of sediment that had a lot of iron-bound phosphorus and organic phosphorus, it is essentially adding those minerals to that sediment layer is providing binding sites for that phosphorus. So if it leaves the iron, it's going to attach to that aluminum or that lanthanum. So, having said that, so what I did was, again, these are just planning level, and these looks like a lot of money, and it is a lot of money. And so what we did was, if we're using, and the reason alum is typically less expensive than than Utazorb. But unfortunately, the source of alum is down at the Columbia River. And so it's got to come all the way up to the top of the state. And that makes it a little bit more expensive. Again, it might, you have to get specific quotes for this, but for these treatments, like the $311,000, we assumed that we were going to do a treatment once a year for 20 years. And that's how you got your doses. This is how much it would cost every year for 20 years to treat this lake and to build up enough of those minerals in the water column to be able to provide long-term phosphorus binding capacity. Okay, so that's what these two numbers mean. So every year you're going through and doing this lighter, what we call stripping dose, and eventually, over the years, that will build up to be your end goal of then not having to do it. That's quite a challenge, financially. I totally understand that. However, there are certain lakes where they've been able to do a treatment and then wait maybe a couple of years. They don't have to do another treatment again for a couple of years. So again, based on the information that we have in on the sediment, this is what we calculated that would be necessary to be able to bind that phosphorus.
Mark, is this for the whole of the two basins?
This
You're
is
not thinking strategic areas. This is all of the East Basin, all of the West Basin.
Yeah, that's. I'm really glad that Rob brought that up because just like we don't know with our aeration application, we don't know if the entire lake is anoxic and would need to be aerated or only portions of it. The same thing is with alum or Utazorb. There may be only portions of the lake that are anoxic that would need to be treated with these minerals to bind with the phosphorus that would be released during anoxic conditions, right? And so it may be just a fraction of that versus, you may not need to treat the whole lake, or you may not even need to treat the West Basin, or you just need to do portions of the East Basin. So again, it's just a matter of getting more information about the specifics of the entire lake, the conditions of the entire lake, to be able to put together a more comprehensive approach to what would need to be done. I covered most of that. And then watershed, we talked about, I'm sorry?
Quick question. Do any of the treatments there affect fish?
No, neither one of them do. Now, I take that back. So, of course, if you do a treatment incorrectly, it can affect the fish and in other aquatic life. Particularly, I mentioned the aluminum sulfate. That is, it goes in. It's aluminum in an acid carrier, so you're reducing the pH of the lake as you're putting it in. But if you're putting enough of it in that there's a risk of reducing the pH too much, then you just buffer it, and so you don't do that. And so you adjust the pH of the material going in so that it doesn't it doesn't lead to a reduction in the pH in the water column, if that makes sense. It's probably way too long of an answer for you, but it's like, if you do it right, no, I guess that's all I should have said. Yeah. All right, so watershed management options. And Rob touched on this a little bit too. Maintain the current systems. Now, one thing I want to expand a little bit on this, because Rob mentioned the groundwater element in this area, and how the stuff flows through the groundwater into the lake or into the creek. And as we were driving around today, and you notice that there's like standing water in all of these fields, right? And a lot of the fields that are adjacent to Cougar Creek. Groundwater, or the water table, is really, really, really high in this area. And so if you think about all these septic tanks that are in here, with their drain fields that are a couple, 3 feet below the surface, right? They may be only that far away from the water table. And so there's not a whole lot of area or not a lot of soil for them to take up the nitrogen and the phosphorus and remove it before it gets into the groundwater and goes to the lowest point, which is the lake or Cougar Creek. So, that's something to be considered. Your septic tank might be working fine, but the groundwater table is so shallow or so close to the drain pipes that it's just not functioning. So at Newman Lake over in eastern Washington, they're doing a trial with these package plants, which are essentially their septic tanks where all of the activity, instead of using the soil in the ground for phosphorus removal, they're using a series of containers and shifting the water from one to the other, to the other, to the other, essentially a miniature wastewater treatment plant. And the water that goes out of these is already treated. You're not relying on the soil to absorb the phosphorus and the nitrogen. It's already taken care of. So they are in these in Newman Lake, in the areas that the homes that they're trying this on are homes that are built right on the lake. It's relatively steep and rocky. There's really no soil to take up any of the nutrients. So they're trying this out as a way of being able to, be able to keep your house there, but still not have a negative effect on the lake. So that's an option that may be coming on down the road. It might be a little bit more affordable down the road as they refine the process. And then watersheds, again, reduce fertilizer use, establish buffers between agriculture and streams and between lawns and streams. So what that does is that, remember that overland flow that we were talking about in the watershed? Instead of that going right to the creeks or the lakes or the streams, it goes into a buffer area where plants can take up the nutrients and intercept it before it gets to the lake. And this is also a goose deterrent too, because geese they like to be able to see where they're going and like to be able to, like if they're in the lake, they want to look at the lawn and say, oh yeah, there's nothing there that's scary, so we'll just go up one over there. But if they can't see the lawn, then it's more difficult for them to go back and forth. So it's a little bit of a goose deterrent as well. And then just general public education to folks in the watershed, the benefits of the BMPs, the reducing the fertilizer, the reducing the manure applications, agricultural practices, the buffers and stuff like that. Just making sure that folks are aware of all of the things that you can do to protect your lake. And then we talked about future monitoring, some of the stuff that we can do to better get a handle on what's happening in this lake, so that then when we're starting to have some serious conversations about engaging with some of these treatment options, we know with more assurance what scale of treatment is going to be necessary in order to be able to improve the conditions of the lake. And then what I'm going to do, if you don't mind, I want to make sure I leave plenty of time for Elizabeth. So we'll skip kind of through this. Remember your questions, and then Elizabeth is going to talk about some funding options, and then we can have some kind of questions between the funding options and the management activities.
So I'm just going to go over some potential funding options for a lot of the management options that Mark just discussed. And so this table provides a list of some of the grant opportunities that are out there. A lot of them will be able to cover quite a few of the management options that Mark just went over. So the first row, of course, is the grant agency. As you see on the top, there are a lot of federal agencies that I started off with, and unfortunately we don't know at this time where that's going to go and what will be available, but they have some great programs there. And the second row is the grant program within those agencies, and then you have the different, what I called the restoration methods. Those are your chosen management options that Mark was just going over. And on the fourth column, you have all the entities that are eligible for those different grant options. This exact table can be found in the LCMP, so you can go into the LCMP and click on that grant program, and that'll take you to the website for that program, and you can find out more about it, whether, when the RFPs are available, the dates they're due, the maximum grant amount, and it'll give you a contact person as well at that agency. So this is just a continuation of that, and these, as you see, are mostly state agencies, including the Department of Ecology, where I was for a long time. For example, the grant program that might cover the septic is covered here. The Water Quality Combined program can help cover the cost of putting in some of the new septic designs around the lake. That's just an example. So looking at the eligible entities, you can see that a lot of them are local, state and local governments and special purpose districts. And a lake management district does count as a special purpose district. So I just wanted to make that point. I'm going to cover lake management districts in just a moment. There are some for nonprofits. They're only eligible for a few, and they're a little bit more specific, a little bit more picky, if you will, on what nonprofits they will allow to apply for some of these grant programs. So looking at lake associations, and this is kind of actually new to me. I don't know if there are any really formal ones in Washington State. There are some other, quite a few actually back east in the Northeast. They're typically set up as a 501c3 or a nonprofit, and they're usually formed to protect a specific lake. And so in some situations, actually, some of these associations are set up like HOAs. So they're technically considered a 501c4 organization. Lake associations play a critical role in lake protection through fundraising, education, outreach, collaboration with local agencies and governments. Some of the advantages are that they're not really bound by county policy necessarily. So, for example, a county has specific regimen that they have to go through when they put out an RFP or when they hire a contractor. A lake association as a nonprofit would not have to go through all of those methods. Some of the disadvantages might be that the nonprofits are not eligible, as I was mentioning, for some of the grant opportunities, including the two that work on lakes through the Department of Ecology. A nonprofit is not eligible for that. And also there's no real requirement for a resident or landowner in the watershed to provide funds. So you're counting on donations. And so this is a lake management district. That's a little bit different. These are set up by RCWs, by a particular RCW, and it's initiated by a resolution of intention by the city, town, or county, or it can be initiated by a petition. And if it is initiated by a petition, it's from the community. The petition should be signed by 10 landowners or owners of at least 20% of the acreage of the proposed district. The process includes a public hearing and a vote. It's a very regimented methodology that they have that you have to go through. It's a simple majority on the vote that can take 8 to 10 months or longer for a LMD to be formed and can operate for a period of up to 10 years. And the purpose of this RCW that the state legislature put into place was to establish a governmental mechanism by which property owners can embark on a program for lake improvement and maintenance for their lakes in general public. And so on the section 4, did you want to go over all of the questions, any questions from section 3 and section 4 now, or should we discuss next steps or do the questions?
Yeah.
Maybe all three of us can stand.
Next steps are just, we've got a month to Yeah, I guess we are right here. And then you guys have this from April 1 to April 30th to comment on the LCMP, which is on the website.
We're working on making it available and should have it up on our website tomorrow.
Okay.
Cross fingers.
And then we will have some time to respond to your public comments, and then the final report will be end of May this year. And so, yeah, let's just.
Questions on section 3 or 4?
Whoops.
Yeah, maybe it's just kind of adding to what you were just saying there of like, okay, so the report is due by May 31st. So who or what are the decision makers in this process?
The decision makers as
to what?
So like you're going to do a report, but is that saying, oh, we're starting a lake association, or oh, we're going to do the phosphorus treatment thing? Like who's making those decisions for what exactly is going to change?
So what our role in this is to analyze the data, analyze the lake, figure out what's going on in the lake, make recommendations about what can be done to help improve the lake, and then it's the decision up to the county and you folks, you lake users, to figure out how you're going to implement or how you're going to form an LMD, if that's what you want to do, or, you know, it's our role is not to decide for you. Our role is to provide the information to help guide you to make a decision about what needs to be done.
And then one other question. Don't want to
Sure.
hog the mic, but when you talk about waterfowl management, maybe I'll speak for most Western Washington people. We love the swans. We hate the geese. I don't know if that's a popular opinion. From everybody that I talk to, it is. So you mentioned both.
That's a common opinion, right?
So like the swans come and they're here for a period of time and they're gone. And then you kind of mentioned like the geese, that's a little bit more like they stay. Is the good natural order the temporary migration? Like we shouldn't be having the geese the whole time? Or are both of those waterfowl being here concerning? Does that make sense?
Right. The biggest, so the geese, they typically, historically, they would just migrate through and go to bigger and, to greener pastures. But now that we've greened up the pastures everywhere with breadcrumbs and, in fields and all that kind of stuff, they have easy pickings. And so they've kind of, stayed around. So, there certainly is an advantage of discouraging them from staying around. And one of the things, they are a protected migratory species, so you can't just. You can prevent the next generation from becoming, you can oil the eggs, you can addle the eggs, you can essentially make their eggs non-viable so that they don't raise their next generation to say, there's some good food there, you don't got to go nowhere. So, that's what a lot of people do is they oil the eggs or addle the eggs or something like that to keep the offspring from hatching.
And also try to get rid of your lawns.
Yeah, right. And like try to remove the buffet essentially. Yeah.
To your knowledge, has the lake ever been treated before?
Can you repeat that question?
I was just asking if the lake has ever been treated.
I don't know if it certainly hasn't been treated, to our knowledge, with any phosphorus sequestration products. Whether it was treated with an algicide at some point, I don't know. I haven't seen it in the records that it has.
And as far as the budget goes, do we have, I know grants are great. We paid for the study for this, but do we have any money in the county just to apply for the cleanup of the lake? Nothing. But yet we paid for the research for 2 to 3 years.
This, all of this research was thanks to grants that we got from the Department of Ecology. So we got 2 grants from Ecology. The first grant funded our efforts to formulate a monitoring plan and execute 1 year of monitoring. And then the second grant allowed us to hire consultants to do this work for us.
And the same program does allow for treatment, but the maximum grant amount is $50,000. I know.
Is there grant money for
For alum treatments.
for treatments? But like but as far as if there's more monitoring that's required to be able to refine a treatment, is there money for that? Or since we've already applied for the monitoring money, is that purse empty?
You could always go for it.
Yeah.
You could always try.
Yeah.
There's only about 250 or so thousand a year available in the freshwater algae grant program, and so that's what, 4, maybe 5 projects, and so that's but the good thing about that program is it's funded by state money, by license fees, so there's no reliant on the federal agencies or anything at this time, and so that's the great thing about those 2 programs, the Aquatic Basic Plan and freshwater algae program.
So can we take that money now and just start some kind of treatment? And then just wondering.
Yeah, you could apply. It's
I'm sorry, can you repeat her question?
Yeah, so she was wondering if we could take the funds and start with, I assume, one of the alum treatments or Utrisorb. The grant application period is in the fall and through December, and then you would, if one were successful, the grant would start next July 1st, so of 2026.
And who would apply for the grant?
It would need to be an hi Anna. No, it would need sorry. It would need to be an entity, so city, county. It could be a special purpose district. So if a lake management district is a special purpose district, yes. And then, of course, if that were the case, an LMD would then funnel the funds to a contractor to actually do the work. So it can go through an LMD. Those 2 funding opportunities are not available to nonprofits, however. There were others that were available to nonprofits, but not those 2, not the freshwater algae control program, only to special. I'm not sure why they called it special purpose districts.
Like in the state of Oregon, for example, there happen to be there's like watershed councils, other nonprofits for lake associations. In Oregon, they don't have lake management districts. Here in Washington, you do, which is amazing. But there's nothing that says you can't have both. You could do a lake management district and you could do a nonprofit.
Yeah, absolutely.
And then you'd be eligible for all the grants.
And hopefully they get
Pretty
along.
much.
No, just kidding.
Right? But to be clear, and this is why Mark was saying it's really up to you folks, is we're not going to shy away from saying that whether you form a lake management district, an association, it takes time and energy, right? To get it off the ground, to get people dedicated to being on a board, to being part of the process, to understanding how you interpret the lake management plan, figure out your next steps. You don't need to be a scientist or an engineer to do that. But what I'm saying is that it's not like you hand it off to Anna and say, run with it. That isn't the way it works, whether it's an association or a lake management district. You might work with Anna to figure out how to do a lake management district, but it's not really falling on the county to do that. It's really about all of you saying, we really want this, and this is how we're going to do it.
My question relates to what's going to come out in the final report, because right now a lot of the tables showed kind of yes, no, possibly. Mm-hmm. Is it possible that the final report will have a little different ranking systems that say we strongly recommend a couple of things that would be high value, and then some other things you could do, and give us a little more than just a yes, no?
I think that's a really, really good comment. So I would say once the report comes out, take a look at it. And if it still doesn't meet what you're thinking based on your comment right now, definitely submit that comment. Okay. It's going to come out tomorrow. So It's not like we can change
go
it between
rewrite it
now and
tonight?
tomorrow, right? So, but it's a good comment, because we do want to make it usable, right? It's not, certainly there's a bunch of geek stuff, right, that we presented tonight, but we also want it to be usable. And so, and not just usable to Anna and Josh and the county, but to all of you, right? So if you see parts of it that don't look usable, then by all means make that recommendation.
And does it matter if it's a public lake or a private lake? I'm getting a grant or who does it?
I'm not.
Yeah, no, they,
Is there such thing
yeah,
as a private lake?
yeah, there are some private lakes. I think at the Aquatic Invasive Plant Program, it has to have a WDFW boat ramp, but for the freshwater algae program, it does not have to. It can be a private lake. So for Cyanobacteria, it can be a private lake, but luckily you're not having to. For Wiser, you're not having to deal with that. But for example, Echo Lake in is it Snohomish County? I think it's still King County. For example, that's surrounded by residents. There's no public access, but they still got a grant. So that is possible.
A different sort of question. Could this be subject to a TMDL?
It is subject to a TMDL. Yeah, it is subject to a TMDL because just recently the ecology started using, for lack of a better term, cyanobacteria as a to make it a Category 5 on the list. Total maximum daily load. It's under the Clean Water Act. If a state has found that a water body is not meeting the Clean Water Act, I'm really messing this up, but they are required to do a TMDL. We, the three of us, are in conversations with the folks at Ecology to try to determine how these LCMPs, which, by the way, is something that I did when I was in there, is I put this template and the guidance together. And I did that on purpose to make it really thorough, much more so than they used to be. But we are in conversations with Ecology, different folks from when I was, or from, my predecessor, or the person that has my job now, to see how these LCMPs can be used for a pollution control plan, which is it's just like a TMDL. So it can be used to move the lake forward out of it being a Category 5. Because right now, Wiser Lake is a Category 5. On
Does
the
that make sense?
Yeah.
So it's like, usually TMDLs are applied, total maximum daily loads are applied to watersheds, right? And it's usually anyone who has an individual pipe that discharges, wastewater treatment plant, industrial facility, they need to get a permit. Mm-hmm. And that handles the individual sources. TMDLs are designed to handle all the non-point sources in a watershed. What's valuable about what Elizabeth's saying is it's possible we can work with Ecology to figure out how to make the lake management plan almost like a compliance plan on how to get it out of Category 5. Mm-hmm. The super awesome advantage of that is it's not as regulatory driven as a TMDL, which is a lot more of a hammer coming down. Right? You still have to comply with things, you're still going to have to show progress, et cetera, but it's not as onerous of a regulatory oversight as a TMDL would be.
But if you were under a TMDL, would it be better under a financial? I mean, wouldn't you be higher up on the list for financing?
Yes. So as a Category 5, you do have some you are a priority, if you will, for funding.
So can you clarify that though? Because what's really important for them to understand is that when a TMDL is issued, you comply. You're required to figure out how to pay for that to comply. But with the lake management plan, you have a lot more flexibility, right? Is that?
Oh, yes.
That's
yes.
what we're trying to get at.
Right. And so a pollution control plan is something that's in place of a TMDL. So it's like, it would make it a category, 4B, I think, or something. So it's in place of that. The problem is that ecology doesn't have the staff to come and do a TMDL for Wiser Lake. It would be years before that happens. They're still working on TMDLs from, that were put into category 5 years ago, many years ago. And so if we were able to move this into a part of starting on the path to a category 4B or a pollution control plan, we won't even have to go the TMDL route. Hopefully we can improve the condition of the lake to the point where it could be taken off of, and not a category 5. So.
Yeah, I'm with Department of Ecology. I work on TMDLs. I'm a water quality lead for this area. So, yeah, they summed it up quite well. We do. The state does prioritize the TMDLs. Even these alternative plans would be a pollution control plan. So when Elizabeth is talking about a 4B option, that would be any control plan outside of a TMDL that reduces the problem, and that would be the loading of phosphorus. I'm not sure how those short-term treatments factor into that equation in terms of a TMDL. In terms of pollution control, is it really pollution control? That's something that we could figure it out. But just off on the surface, the good thing is there's local interest, partners to move forward and take care of the water quality issues. Elizabeth was talking about our most recent water quality assessment that we tried to do every 2 years, the state does, and there's a draft assessment of harmful algal blooms on this lake. So we have a water quality issue confirmed, and state says sure, based on the data we have. I think in this case, since TMDLs, they don't have a regulatory mechanism to address a non-point source pollution that doesn't have a permit to discharge. And that's what I believe is occurring in this watershed. I don't think there are any major point sources. And so the TMDL would really address those major point sources, legally binding. However, when it's just land use practices that are not necessarily under a permit that the state issues, there might be local codes that's not a permit, that's just a code. A TMDL doesn't address those entirely through a permitting process, but it does help identify and quantify where the pollution source might come from and how it can be regulated, whether it's voluntary or under a permit. And then finally, I think I'm not sure exactly how the grant scoring processes go when we're ranking them through the Department of Ecology, is just those grants speaking. But I know if a watershed has a TMDL on it, they tend to have a certain score. I don't work in the grant world. I'm not sure what that is, but if there is a Plan 4B, like a pollution control plan that was suggested here, it's probably going to rank the scoring of a grant proposal to some degree. That will factor in as a higher ranking to likely say, okay, we've got project partners, a local community ready to work and address the water quality issues. So that's all going to really help for grants. So I hope that helps.
Yes, thank you.
And if you have any more questions, I'm James Cardoni. So.
Thanks. Use the terminology much better than I do, but thank you.
Just maybe a little technical question. With the aeration as one of the options you were talking about, looked like a pretty significant system. Is that aeration going deep into the sediment? I guess I'm thinking like you mentioned, it's so windy, and days and weeks when it's windy, I mean, everything is brown out there. You can tell that it's really churning everything. So the aeration that you're talking about, I'm assuming, would be achieved not by what the wind is already naturally doing with the churning. Is that correct?
Right. And so what it might be a situation is if the lake is becoming calm at night, then maybe the aeration only runs at night. When the wind isn't doing that for you, right? Or maybe at night, or in areas where the deep area where maybe it's sheltered from the wind, and it doesn't get mixed as much as some of the shallow areas do. So it wouldn't be, I don't anticipate it being throughout the entire basin, but just kind of selective areas where it would need it. Great question.
And just to piggyback on that, the aeration system, it's a possible recommendation.
It's a possible recommendation,
right?
Yeah.
And we need to do some more information gathering and collect some more data on dissolved oxygen, because if we find that dissolved, that there isn't much variation in dissolved oxygen levels, then we may not need an aeration system. So, going back to kind of your point that you made, that there are recommendations to do certain things and not other things, and maybe some things, those possible things, I think, depend on information that we continue to gather, and depending on what we find, we might go through with those management actions.
Yeah, and that's a good point. It's like, lakes are really dynamic and really complex, and this is the first study that was done on this lake, and so we don't really know what was going on. And then a lot of times you do your initial studies, you come up with more questions than you have answers to. And so, it was a very thorough study with very good data generated from it, but it also raised a few questions. And so that's the benefit of ongoing monitoring of water bodies like this, is that you can kind of see how the lake changes from season to season and from year to year, and particularly you can validate whether or not your treatment options are actually working or not. So it's not like, this is, we're not recommending this is a one and done study. This is kind of the baseline study of what conditions the lake has been during the study period, and then what's going to be necessary in order to recommend further options. And then, the goal is to continue to monitor to make sure that those management activities are doing what they need to be doing. And that's where a lake management district or some sort of a formal structure is really important, so that the responsibilities and the data collection and the data management is all kind of, the group is kind of following through with the process and with the plan in kind of an organized way, and, in raising money where possible to be able to carry out these activities for the long-term health of the lake, instead of, relying on the county to do it because they just don't have the resources. Yes.
Is there any value to or possibility of training or recruiting some of the residents around the lake to take water samples at a much more frequent time, and especially at times when some of the blooms are showing up, weekly?
Absolutely.
or whatever? Those of us that live on the lake, if we knew what you wanted, I'm sure I could dip a water sample if we had some place to get that analyzed.
Absolutely. And as part of this process, as part of this, before Anna and her group collected data, they put together a quality assurance project plan that laid out the steps that you're talking about, is what to do, how to do it, and where to do. And that can be, something like that can be tailored more towards the citizen science, I guess, perspective of data collection, so that the key of that is making sure that you are using proper methods to collect the data, that you're doing it the same way every time, and you're doing it in the same location and all of that. And then the labs, there's one in Seattle and there's one out on Friday Harbor that I send all my samples to, so it's fairly close for you guys. So,
And there's one right here in Bellingham at Western Washington University.
Oh, of course, yeah. I didn't know you did your own lab, or phosphorus analysis. That's great, yeah. And there's one right here sitting in with us. So, but yeah, I think that that's a fantastic idea. And, excuse me, Angela has, she has students too. And, there may be some synchronicity there where they can help out with this project as well and kind of, provide guidance, for, I don't want to throw her under the bus or anything like that, but you got a great institution right down the road that does some fantastic work, so.
Yeah, the main stipulation is that we would still need funds for that kind of monitoring work. Lab analysis does cost money, so we would still need to probably apply for some sort of grant funding to fund this sort of work. But I think it's a wonderful idea to recruit local help with something like that.
Mm-hmm.
I'm from Birch Bay Village, and I'm here because we try to take care of our ponds and lakes as well. And we have a group of volunteers that go around and we do sampling, and we do dissolved oxygen testing, and it can be done, and it's just folks can do that, and I think it's really great if you can do that, and it gets you more in touch with the whole thing.
I do just want to be mindful of the time. It is after 8 o'clock. We're happy to stay and answer more questions, but we also don't want to keep you guys.
Once you post the report, you'll send out an email or whatever.
Yeah. So we'll send out a notification as soon as the report is available on our website. I should give you fair warning that it is a lengthy report. It's over 100 pages long. So it does have some technical information in it.
If you have a problem falling asleep at night,
yes.
It's a good remedy.
But if you need help dissecting any of the sections, please reach out to Mark or our program, and we'd be happy to walk you through any sections that might be confusing. All right. Thank you, everybody.
Thank you.